Thanks to Ground News for sponsoring today's video. The search for alien life is a difficult one. How would we know that aliens exist? An obvious answer would be if they visited our planet en masse. If, like in the film Independence Day, their saucers floated above every city in the world. Or perhaps if their envoys met with us, shaking hands with our world leaders while cameras broadcasted the moment on national television. Or maybe if they started trading with us and their inventions and resources began appearing in our everyday life. There is, fortunately or unfortunately, not much evidence that this has ever happened. But while visits from aliens would certainly be preferable, that's not the only possible way aliens can prove their existence to us. It's much more plausible that they would do so with their signals. We've spent a lot of time on this channel discussing some of the reasons why aliens might not have talked to us. But on the flip side, what are the strongest pieces of evidence that they have already done so? Which signals are considered the best candidates so far for a message from an alien civilization? I'm Alex McColgan, and you're watching Astrum. And rather than explain why we haven't heard from aliens, today, let's look at where perhaps we already have. Obviously, when it comes to alien signals, there is some ambiguity as to what exactly we are looking for. Aliens are, after all, alien. We are not quite sure what to expect from them, as they will likely have evolved in conditions different to our own, and may well have cultural outlooks that make perfect sense to them, but are completely obscure to us. Their definition of a good way to say hello to the universe might be very different from ours. Researchers looking into possible signals from other planets have to remain very open-minded about what an extraterrestrial signal might look like. But that means such signals can get confused with signals from natural sources that we simply do not understand yet. How can we tell the difference? Let's look at a few examples to show you what I mean. In 2019, as part of the Breakthrough Listen initiative, the Parkes Murray-Yang telescope in Australia was observing Proxima Centauri, the star nearest to our own. It was recording data to learn more about stellar flares. But when SETI researchers, a collective term for the search for extraterrestrial life, went over the data it had collected sometime later, they found something unusual. A signal which later came to be known as BLC-1. Could the star closest to our own actually harbor advanced alien life? This signal was fascinating, as it could not easily be explained away by conventional sources. It lasted for several hours, which is longer than the time it normally takes a human satellite to pass by overhead. It had signal drift. Its frequency was shifting, which implied possible movement relative to the telescope, so it likely wasn't coming from a stationary object, creating interference on Earth. One of the most compelling things it had going for it was its thin, narrowband signal. In nature, radio waves are never so narrow in their range. They always fluctuate. Unless there exists some natural source out there we've not discovered yet, the only thing that produces such a concise signal as this is technology, either human or alien. When no obvious explanation for its existence could be found amongst human sources, naturally scientists wondered, could this be the signal from alien life they had been looking for? Along with the WOW signal, which we looked at in a previous video, BLC-1 is one of the strongest candidates for signals that may have been created by alien civilizations. And yet, even this signal has its drawbacks. Scientists could not link it to any sources of obvious interference from technology on Earth, but on closer examination of the data, it did match other radio wave signatures that came up on the other days of the search. Except these other signals occurred no matter what direction the telescope was pointing in. Neither were they able to detect BLC-1, the signal from Proxima Centauri, with later observations. So while they don't know exactly what interfered with the telescope to produce BLC-1, the odds of it being interference are nonetheless quite high. Let's take a look at another candidate, the somewhat mouthier SHGB02+14A. When one of the first SETI experiments, Project Ozma, was started in 1960 by Frank Drake, it began on the basis that if alien life were to communicate with the rest of the universe, they would do so at frequency 1420 megahertz. The logic behind this was that this was the frequency emitted commonly by hydrogen, one of the most widespread elements in the universe. Aliens looking to establish communication with other civilizations might use such a frequency as a sort of common ground, a wavelength that probably holds a special significance to any race. This might have been a leap of logic, but it certainly made SHGB02 plus 14A of interest later. Because this signal, let's call it SHG for the rest of this video, for the lack of a punchier name, did indeed broadcast at this exact wavelength. SHG was spotted on 3 separate occasions in 2003, using the Arecibo telescope and the computational power of 5.2 million home computers as part of the SETI at Home initiative, a rather cool program that sadly is no longer running. SHG had no obvious explanation for its origins in nature and didn't appear to be interference. But it was also too weak to say for sure whether it was clearly technological or not. On top of that, its location was peculiar. It came from a spot devoid of stars up to 1,000 light-years away from Earth. And although it experienced drift, it did so in a manner that made scientists suspicious. If a signal originates from a planet, then there are a few things we might reasonably infer. A signal being broadcast from a planet, either on the surface or in orbit just above it, would likely experience some Doppler shift as it alternated from moving away from us to coming towards us through the circular path it was taking in space. There would also be moments where it dropped out of view entirely as it moved behind the planet. While SHG did indeed experience fluctuation in its signal frequency, ranging from 8 to 37 Hz per second, this would only come from a planet that was rotating 40 times faster than Earth, which seemed high. It was also strange that each time the signal was spotted again, no matter where it had been when it had last been sighted, it always began at 1420 megahertz. The odds of you looking at an orbiting transmitter on 3 separate occasions and each time spotting it starting off at the exact same location is incredibly slim, which is what you'd need for this to make sense. This observation pointed to it being more likely SHG was some kind of glitch in the technology. By looking at the process by which the BLC-1 or the SHG signals were evaluated, we gain an interesting insight into how SETI determines whether something might be of alien origin. To me, it is a method that lines up best with this quote from Sir Arthur Conan Doyle. In the words of his famous detective Sherlock Holmes, "When you have eliminated the impossible, whatever remains, however improbable, must be the truth." Each time researchers came across a new signal, they began by eliminating all possible alternatives. Could it be interference from a passing satellite? Is there anything in nature that we know of that could be producing this effect? Can we, in any other way, explain why this signal is here and behaving the way that it does? So far, alternative explanations have been found for these contenders for alien communication. Even on the occasions where human interference can be ruled out entirely, that still leaves open the possibility that these mysterious signals might just be undiscovered natural phenomena. And that is precisely the current discussion around the last candidate for alien signals I'd like to leave you with today: fast radio bursts. If an alien civilization were ever to be detected, it might not be intentional on their part. Powerful engines activating or beams firing all might release bursts of energy that give away a galactic civilization, which makes fast radio bursts, or FRBs, interesting. They are, just as the name suggests, very fast bursts of radio waves. We have detected hundreds of these strange millisecond-long bursts across the sky. Scientists theorize that there might be thousands of them occurring every single day. They have mostly been detected outside our galaxy, but one was detected within the Milky Way in 2020, so they're not completely foreign to us. They seem to be coming from extremely powerful magnetic fields, and as of yet, scientists have no clear idea about what their origin might be. There are plenty of theories. Perhaps they are emitted by neutron stars or maybe black holes, but there is no proof that puts any one theory over another, including that of alien technology. The Keim Radio Telescope in Canada has a unique design that makes it ideal for detecting these fleeting blips in the cosmos. Avoiding the pitfall of other telescopes, rather than pointing at any one point in space, Keim's multiple cylindrical parabolic reflectors are able to draw data from an entire swathe of the sky at the same time. It began detecting in 2018 and is still going strong to this day. It has detected FRBs that are repeating, as well as one that is definitively associated with a magnetar star. Perhaps all FRBs can be associated with such stars. Perhaps not. But that is just the point. Perhaps one day we will be able to identify the origins of all FRBs, and will know that they have a perfectly natural origin. Perhaps the search for alien life will have to begin afresh. But there is always that tantalizing hope, that slim possibility that one day, as scientists rule out signal after signal, that finally one will come in that defies alternative explanation. If all other explanations can be ruled out, if we can say for certain that no natural source caused this, then, in the words of that great detective, we will have no choice but to accept the improbable. So these are some of our best candidates for signals from another planet, but even they come with massive strikes against them. We have not yet found a signal that conclusively points to the existence of aliens. But that is not to say that we never will. It's never aliens. Right up until the moment where it is. We'll probably never know whether the WOW signal was humanity's first contact with aliens. But it is amazing to think about how much we have discovered about the depths of our solar system, and yet we still find it difficult to agree on events taking place on our own planet. This thought is what inspired Harleen Carr, a former NASA engineer turned Rolls-Royce employee, to start a news platform. She'd been working for Rolls-Royce selling and managing jet engines. One day, she got a terrifying text about a double-engine failure. That was the Malaysian Airlines Flight 17. It was amazing that we had to wait hours until a camera crew, a journalist, went to the site and figured out what happened to the plane. And to be honest, we still really don't know what happened to that plane. She started to think about how to engineer a better newsreading experience that would help people verify information in real time by comparing multiple perspectives from journalists on the ground and around the world. And just last week, more than 8 years later, an international team of investigators released their analysis of what actually happened to Malaysian Flight 17, which you can read all about on Ground News, the platform Harleen built. If you'd like to take steps to think more critically about the news you read, go to ground.news/astrum to learn more. Thanks for watching. If you missed the previous Wow Signals episode, be sure to check it out here. A big thanks to my patrons and members. If you want your name added to this list, or you simply want to support the channel because you like what I'm doing, check the links below. All the best, and see you next time.